Hello everyone, and welcome to Highlights of Modern Astronomy. I'm Adam Frank. I'm a professor of physics and astronomy at the University of Rochester, and my job for the next few weeks will be to take you through the entire spectrum of modern astrophysical theory, pretty much everything we understand about the universe. It's the human story of the universe in the sense that it's what we understand about the universe that we live in. There's so many open questions, so many giant mysteries that we face. But in spite of that, we still really have come an amazing distance in understanding our place in the universe, where the universe came from and where it's going, where we fit in to the entire spectrum of cosmological history. So let's get started. Today is the introduction, and the question we really want to start with, it's the question that everybody asks really when you first talk about astronomy. There's lots of interesting things that, interesting questions that people first ask me when they find out I'm an astronomer. What is a black hole? When did time begin? But really the question that everybody's most interested in is, are we alone? So let's talk about that question as a way of framing the entire course. Okay, so here's a beautiful quote that goes quite a ways back. In the universe, nothing is the only of its kind. In other regions, surely there must be other Earths, other men, other beasts of burden. And that's Lucretius from the 1st century BC. And that's really the obvious question. We find ourselves a sentient species looking out at the night sky and wondering, are we the only ones? Is this the only time this has happened? And we see that there are so many stars that the natural answer wants to be, of course, the stars must be populated with other intelligent species. But as we're going to see, the numbers, if you look at them, it may be quite possible that intelligent life, in particularly species like us that can look back on ourselves as we're looking out at the night sky, may be quite rare. And so we have to ask this question one piece at a time in order to really know what the boundaries on the answer might be. So our approach, which is the modern astronomical approach, comes through something called the Drake equation. And this actually came about when people were first beginning to think about trying to search for extraterrestrial intelligence through radio waves back in the early 1960s. And the Drake equation is really a formulation that helps us categorize our ignorance. It tells us what we know and what we don't know about the problem. So the Drake equation looks like this. We have, what we're interested in is the number of intelligent species that are out there right now that we might be able to communicate with. The first factor that goes into the Drake equation is the number of stars existing in the universe right now, existing in the galaxy right now, because usually we think of this in terms of the galaxy. The next term would be the number of planets orbiting each one of those stars. So it's obviously, if there's no planets, you're not going to get life. Now, as we go through this, notice how we're touching on different aspects of astronomy. That first term, the number of stars, really is a question about how many stars are there? How often do stars form? How long do they live? When do they die? The next term is how many planets there are. And that brings up the whole question of the origin of planets. Do planets form very easily around stars, or is it really quite rare? The next term is something we're going to have to go into quite a bit, which is the fraction of habitable planets around each star. So if you have planets, that's great, but are those planets in a place where there could be liquid water existing on the surface? That's how we right now define habitability. The next term is the fraction of those planets that are habitable that actually can form life. Does life evolve on every planet that's habitable, or is it that even if the planet has the conditions where life might form, maybe life doesn't make it? The next term is the fraction of planets that actually have grow intelligence, that go on to develop intelligence. Now, this could be intelligence like perhaps dolphins, or it could be intelligence like of the form that we have. And then the last term is sort of the lifetime, or the fraction of the star's life during which that species is able to communicate. So now what we're talking about with that last term is not just the ability to have sentience, to be intelligent, but also to have developed technology that you could communicate across the interstellar distances. So what we see here in each one of these terms, we're asking a different question about the universe. With the first term, we're asking about how stars form, and we're going to have a whole section in this course about stars. The next term has to do with planets, how planets form. And actually, that's what this first section of the course is going to be about. We're going to be studying planets both in our own solar system and in others. The next term has to do with habitability, and that's also something we're going to be talking about in this first section of the course. Now, these next three terms are really about, they're the biggest questions we can ask. Is life common? Is intelligence common? And really in this last term, the term about how long you're going to be able to be communicating, you're really asking a question that brings us right back to this very moment in our human civilization. What's the lifetime of an intelligent species? Once a species becomes intelligent and technological, and that's really what we're emphasizing here, does the species exist for 100 years in that form when it's able to communicate? Or does it last for 1,000 years or 1,000,000 years? If you look at our own history, it seems possible that, after another few hundred years, we may not make it as a technological civilization. So that is a really important question for us, and it's one that actually astrobiology, this field of thinking about life in an astronomical terms, really addresses. So what we're seeing in this Drake equation is, a big chunk of what we're interested in with astronomy, and then these deeper questions about our place as an intelligent, technological species in the universe. Okay. So let us go on. So the ideas that we need to address to answer this question is we need to understand the size and scale of the universe, because we're really starting thinking about astronomy. So we need to understand how it is astronomers think about the enormity of the universe. We need to think about planets. What are they? Where do they form? What are they made of? How do we find them? Right? Now, clearly in our own solar system we know how to find them, but it's this search for planets outside the solar system that in the last 20 years has just exploded. That question of whether or not there were planets orbiting other stars was unknown. Even though it was asked since the time of the Greeks, the answer to it was unknown until really just 1995 or 1996. And that is remarkable. And we know the answer to that question now. There are thousands, millions, billions of other planets orbiting stars in our galaxy. So we need to understand the question of planets. And then, finally, we need to understand the question of life. What is it? How do we define it? Where might it be in the universe? And how might we be able to find it? So what we always want in science, and this course is as much about how science works as it is about what a particular science, meaning astronomy, says. What we want to understand are what are our guiding principles? What is it that actually tells us how we're going to frame our questions and go about answering them? So since this first part of the course is about planets, what are the guiding principles for planets? Well, number one, what we want to understand are what do the different planets in our own solar system tell us about the general principles of planetary origins and formation? Now, of course, we have planets, we're discovering planets around other stars, and that can be added to this question as well. Now, the other guiding principle that's going to determine how we ask questions over this week is going to be how might each one of these planets fare as a home for life, both in the past and in the future. So those are the two principles we're going to use to guide our exploration, and I look forward to going to the next topic.